Here. All right, we looked at projectile motion yesterday. We learned that when an object is thrown through the air or moves through the air under the influence of just gravity, it follows what we call a parabolic path. And that parabolic path may look like this if it's launched from ground level. Okay, that would be a full parabola, albeit an inverted parabola. Or it might look like this, just a half parabola if it's launched from the top of a building or the top of a cliff. Okay, regardless, they're parabolas, right? Now, in each of these cases, because they're parabolas, we're going to describe the motion in two components, x and a y component, and by an equation in each of those components. For x and for x and y in both of these situations, because it's a parabola, we're going to describe the x component by using this equation, v is equal to delta d over delta t, and we're going to describe the y component by using this equation, d is equal to vit plus 1/2 et squared. Now, yesterday, we learned to solve problems like this. But later on, you're going to learn to solve problems like this as well. We will start off exactly the same way. Now, I don't expect that you'd be able to solve this problem yet, because there's some finer points that we haven't gone over yet of questions like this, but I would expect that if you saw a question like that, you'd be able to start. Because every one of these questions, regardless of whether it's launched horizontally off the edge of a building like the red one, or launched at an angle like a football being kicked for a field goal, regardless, we describe the x component with v equals d over t, and the y component with d is equal to vit plus 1/2 et squared. Every one of these questions starts off the same. Draw the picture as appropriate, and then write down these two equations for the x component and the y component. And then the strategy is simple. Just sub in numbers and get something. Okay, sub in numbers and get something. You learned yesterday how to get something from the red one, and then probably on Monday we'll learn how to get something from the blue one there. All right, we had 3 questions for homework last night. Questions 1, 2, and 3. We see the answers at the bottom of the page here. Which one or ones would you like to go over this morning? All right, 1 and 2 it is. Number 1 says a coin rolls off a table with an initial horizontal speed of 30 centimeters per second. How far is it going to land if the table is 1.25 meters high? We got centimeters here, and we got meters. When we're solving problems involving acceleration, clearly we have acceleration here because this ball is falling, then we have to be in meters, right? We have to be in meters per second. So what I want to do is convert that centimeters per second to meters per second, but I'll do that on my diagram. Here's the table. Here's the coin rolling off the edge with a speed of 0.30 meters per second. All we got to do is divide by 100 there, because seconds is already there. We just need to convert centimeters to meters, and we do that by dividing by 100. The table is 1.25 meters high, and it falls the full height of the table. It's going to follow a parabolic path like this. We want to find out how far from the edge of the table the ball lands. This is a lot like the example question that we did yesterday in class. So what do? No funny angles here, don't have to worry about that. We break it up into x and y components. For the x component, we say v is equal to delta d over delta t. For the x component, do we know the velocity for the x component? Do we know how fast it's moving horizontally? Yeah, we do, Ethan, right? What is it? 0.30. And that's not an initial or a final. The 0.30 is the horizontal velocity the whole time, right? It doesn't change. It would be 0.30 at the top, it would be 0.30 there, and 0.30 there horizontally, because there's no forces to speed it up or slow it down horizontally. So let's sub that number in, 0.30. We do not know what the horizontal displacement is. How far does it go this way? And we don't know what the time is. So not overly helpful to me yet, but that's okay. Let's deal with the y component using the equation that we always start with, vit plus 1/2 at squared. The equation that you learned yesterday is really the equation for a parabola. That was more meaningful to you if you've done parabolas in math class, but regardless, that's what it is. Do we know what the vertical displacement is? How far this ball ends up above or below where it started? How far above where it started or below where it started? Is it, JC?
Negative 1.25.
Good, negative 1.25. Negative because it ends up below where it started, right, down from where it started. And it's 1.25, of course, because you can see clearly in the diagram that that's the vertical component, the up and down component. We don't know what the horizontal is. That's what we're trying to find. Look at the diagram again. Tell me what VI is. And remember, we're looking at the Y component here, the up and down. What's the initial velocity up and down? Erica, you got that? How much of this is up or down? How much of this value right here is up and down? Christine? 0. Right? Look at it. How much of this is up and down? Well, it's 30 centimeters per second horizontally, right? This way, this way. How much of it's this way or this way? None of it. None. 0. So we say 0 times the time is 0. 1/2 of, what's the acceleration? Ariel, what's the vertical acceleration? Good, negative 9.81. We don't plug that in over here for the x component, right? Because it's not accelerating in the x-axis, but it is on the y-axis. And t squared, look, we can solve for t. It's not what we're looking for, but we can do that. We can either multiply by 2 and then divide by neg 9.81, or we can say 1/2 times neg 9.81, get neg 4.905, and then take that over by dividing, whatever works for you. I'm going to multiply by 2, and then I get negative 2.5. Let's divide by neg 9.81 now. And when I do that, I get 0.2548. That equals t squared. And how am I going to solve for t there? We're going to square root that, right? 0.5048. Why did I go 4 digits there? Why didn't I just round it to like 0.5 or 0.50? It's not a final answer. I'm going to need that over here. I'm going to take this number, sub it into this, and then I'm going to take it up by multiplying. 0.5048 times 0.3 gives me a value for the horizontal displacement of 0.15 meters. And sure enough, the answer that they give me is 15 centimeters. All right? So horizontal x component displacement that I'm just solving for right there, 0.15 meters. Is that okay? Listen, we can do these, right? We can do these. On your practice test / unit assignment, there is one of these on there, one of these horizontally launched projectile motion questions. There's also going to be one that's launched at an angle. We're not going to learn to do that until Monday, but on Monday, that'll be the only thing left that you haven't learned on that assignment. So you won't be able to do that over the weekend, but at least the rest of it you will be able to do, at least theoretically. Okay, let's take a look at question number 2 here. It says an arrow is fired horizontally with a speed of 25 from the top of a 150-meter high cliff. Assuming there's no air resistance, how far will the arrow drop in 2.5 seconds? Now pay really close attention to this one, okay? Because this one is tricky. Okay, this one is tricky. This arrow is being launched at 25 meters per second from the top of the cliff. Easy, right? We have a time interval here of 2.50 seconds. Okay, that's unusual. Usually in these questions we're not given the time. The cliff is 150 meters. Look, it follows a parabolic path here, but in 2.5 seconds we want to find out how far it falls. In other words, we don't know if it falls all the way to the ground or not. In other words, if we want to find out how far it falls in 2.5 seconds, does it matter how high the cliff is? Let's think about this. Let's assume that it fell 75 meters. Okay, that's not going to be the right answer, but let's assume that it fell for a second 75 meters. If it fell 75 meters in 2.5 seconds, would it matter if the cliff was 150 meters high or 1,000 meters high? It's still falling 75 meters. So this 150 is really irrelevant. It's what I call blue car phenomenon. What do I mean by that? Let me give you an example. A blue car travels down the road at 100 kilometers per hour for 2 hours. What's its displacement? What are the givens there? Well, V was 100 kilometers per hour, T was 2 hours, and we're looking for displacement, right? What else was given to me? The color of the car. Does it matter? It's completely irrelevant, right? And of course we know that the color of the car is completely irrelevant. This is same deal, completely irrelevant. It's blue car. Just because you're given information doesn't mean it's useful information. Hold on one second here, okay? If it says it fell 150 or it fell the whole height of the cliff, then that would be important. Okay, we're looking for, hold on one second. We're looking for this value here. So we break it into x components and y components. The velocity here, horizontal, is 25 meters per second. We don't know what d is. We do know what t is, 2.5 seconds. So we find displacement here, horizontal, by multiplying those two numbers together. We end up getting 62.5 meters. But that's not what I'm looking for. That's not my answer. That's the horizontal. The vertical is what I'm looking for. So let's go with that. VIT plus 1/2 AT squared. This is 0 again, because it's launched horizontally. We're looking for this. Look, we got all the numbers there. Let's solve for that number for displacement here, okay? 0.5 times 9.81 times 2.5 squared gives me a value of negative 31 meters, or 30.7 meters. Means the displacement vertically, 30.7 meters. Look, I just found something right here that I didn't need, right? How far horizontally it goes. Is that okay? Sure it is. As long as you don't think that's the answer, it's okay to solve for something that you're not looking for, right? So, assignment due on Tuesday, and of course, test on Wednesday, and we'll pick this up where we left off on Monday. Have a good weekend, guys.